I am Lim Chun Yi, the program lead for RIC program. I'm very excited today to introduce you to the world of robotic system, as well as our undergraduate program. Let's dive deep into the world of the autonomous robot. All right. AMR, or autonomous mobile robot, are designed to operate without direct human control. Right? They have the capability to operate and make decisions independently by gathering the information about their surrounding through various sensors, and then make decision, right? And the autonomy in this robot is actually achieved through a combination of sophisticated hardware, such as the sensor, camera, all the different kind of hardware that's mounted on top of it, as well as software, right? And that's why they can navigate through space, plan the routes, avoid obstacles, and complete various tasks automatically. All right. Now imagine that you try to deploy a fleet of this mobile robot in, let's say, a warehouse inside a factory, right? They can actually navigate around the factory floor or the warehouse, and if they see people or obstacles, they can avoid them automatically. They can also transport goods from one place to another automatically, all right? You can see here. And the use of all these mobile robots actually improve the efficiency of the process, reduce operational costs, all right? So that's why AMR is actually now transforming a lot of industry, right? Manufacturing, F&B, and various sectors where manpower may be an issue. So then they are now at the forefront of a lot of innovation. Okay. Now that we have a foundational overview of the mobile robots, let's talk about the building blocks that make this robot come to life, which is the hardware component. Right. So first we have sensors. Right. Sensors are like the eyes and ears of a robot. Right. For example, you can have a camera, right, which is actually shown here in a Limo platform, which we actually have it here as well. They take in the visual information about the surrounding. You have LiDAR, right, which is actually shown there as well. That actually measures the distance of object using laser beam. And then you have IMU, or inertial measurement unit, which allow the robot to know its own orientation as well as the acceleration. Okay. And next we have the actuator. Right? So these actuators are like the muscles of a robot that allow them to move around, do certain things. All right? Commonly you have servos, you have motors, and other actuation mechanics that enable the robot to manipulate its surroundings, be it rotating of wheels or articulation of robotic arm that can be sometimes mounted on a mobile robot as well. Right. Next, we have communication interface, such as Wi-Fi or Bluetooth, that allow the robot to be seamlessly integrated with other components in the system for exchange of information or to work collaboratively. All right. And other components include the human-machine interface. In this case, it could be just a touch screen that's attached at the here in the back of the robot arm that enables the user to interact with the system, as well as get some information regarding the robot status. And we have this control unit as well. This is like the brain of the mobile robot. Right? It can be a microcontroller or onboard computer, or even graphical processing unit (GPU), depending on the complexity of the system. This control unit, right, typically takes in input from the sensors, right, and then execute the algorithm and issue commands to the actuator. Right? So they are the brain. And the remaining hardware are power system, mechanical structure, which are quite self-explanatory. Okay? So the understanding of various hardware components is essential to build a robust and effective robotic system. Which is why for our course, right, RIC program, we actually emphasize on teaching students on how to integrate and innovate with all these hardware elements. Okay? Now, as we move on, we will explore the equally important, the software component of a mobile robot, right, which enable the intelligent behavior in the robots, right? First, we have the control system that manage the behavior of the robot by processing the input from the sensor and generating commands for the actuator, right? Just like human use language to talk to each other, right? Robot use programming language, right, to execute codes, right? So the proficiency in programming language, right, such as C and C++ and Python, are very essential, in order for engineers to translate the algorithm into executable code by the robot. All right, then algorithm, right? These are the the key component that governs the intelligent behavior of the robot. All right. So from path finding or path planning algorithm, which allow the robot to navigate cluttered and unstructured environment, to say image recognition algorithm that enables the robot to recognize object in the surrounding. All right. So these computational methods are the one that is behind the brain power of the robot's decision-making capability. Okay. And machine learning, AI algorithm allow the robot to learn from past experience or past historical data, adapt to changing environment, and make intelligent decisions in order to complete the task. All right. And here we have ROS as well, which stands for Robot Operating System. It's basically a software framework that facilitates the development of robot application. All right. It basically provides a set of tools and libraries for various tasks, such as hardware abstraction, communication between different components, as well as managing the packages in the system. All right. So again, the proficiency in ROS is very important for someone to develop application related to robot. All right. So which is why, again, in our RIC program, the teaching of ROS is actually at the core of the several project-based modules. All right. And last but not least, we have simulation. So sometimes robot typically undergoes testing and refinement in the virtual environment before they are being deployed in the real world. Right? Engineers use simulation software such as Gazebo, right, to test the behavior of the robot under various conditions in order to minimize the error, the risk of error when they are being deployed in the real case application. All right. Now, in RIC, right, students get to dive into the intricacy of various software components to gain hands-on experience in programming and also developing algorithm as well as system integration. All right. This will empower them to apply the knowledge that they learn to create adaptable and very robust robotic systems. Our Bachelor of Engineering in Robotics System should be your first choice. Okay. It will prepare you for a dynamic career at the intersection of system engineering, software development, as well as robotics. All right, allow me to go into details. Right, so in our RIC program, you will dive deep into the world of system engineering, where you will master the art of designing, developing, and also analyzing complex systems. Okay, you will learn how to integrate seamlessly software and hardware components together to create effective and robust system. All right, and you will also gain a comprehensive understanding on system thinking, system engineering management, all right, which enable you to solve real-world challenges by considering the entire life cycle of the system. Okay, from conceptualization to development to deployment of the system, you will be equipped with skills to excel in any stage of the engineering process. Okay, as I mentioned earlier, our program actually places a lot of strong emphasis in programming, especially C, C++ programming, okay, and software architecture and development of algorithm. All right, and we use all this for various purposes. For example, we can develop codes or algorithm for autonomous system. Or we can also use the AI and also machine learning algorithm to improve the perception of the robot and also decision making, as well as real-time control system. All right. And then if you sign up for this course, right, you have to get ready to get your hands dirty in our robotic system lab, okay, where you actually apply all this knowledge here on real-world scenario, which will foster deeper understanding of how real robotic systems are being implemented in real world. Okay, you have the opportunity to collaborate with our industry partners, all right, to work on hands-on project, and thus you will gain a lot of valuable industry experience and build a strong network that might open the doors for future career opportunities. All right, so our program place a strong emphasis on practical application and knowledge so that you can make an impact in your career from day one. Right? So this is the detailed curriculum structure of SIT RIC program. We have a 4-year program. Right? So each year is separated into 3 trimesters. Each trimester is about 4 months. Right, so this is all the detailed module that is offered in every trimester. I would like to draw your attention to the highlighted so-called module here. Okay, these are project module. Okay, in RIC, we practice something called the project-based pedagogy, or project learning through doing projects, in short. Okay, so you can see that projects sort of form the backbone of the entire RIC program. Okay, you see project almost everywhere. All right. Take for example, the year 1 series of project that we carefully plan and craft that basically teach students how to design and assemble a mobile robot platform, the one shown here, right? And then they have to integrate various sensor and actuator on top of them, write the codes for it, and deploy it for real applications. All right. We will also be working with this platform here, Limo, which we can actually have hands-on trying that out later on. You are invited to try that later. So all this actually enables the student to apply all the knowledge, different engineering discipline, to integrate all these components together and work on something that is actually related to real-world application. Okay, this is what we call project-based pedagogy. All right. Now here is the potential career pathway and also the potential employers for the graduate of this program. So this program is relatively new. Our current first batch of intake is actually in year 3 now. In fact, some of them are actually working as an intern in some of the companies here. Okay, and talking about internship, right? Our internship is called Integrated Work Study Program. Okay, this is where students will actually go out to work in the industry for 12 months, up to 12 months. In fact, this is one of the reasons why you should choose RIC. Okay, we have one of the longest internship period among the similar program offered by other university. Okay, this is when I think students will gain a lot of exposure to real engineering work.